Oh, it's the math part.
Guys, you gotta get in our seats, come on. I'll give you a little extra time just to avoid this kind of crap.
No, it is not.
Alright, so what's the next one? I can't remember, what is it? Absolute value. Well, you're gonna like this one, it's one of the easiest ones, you learned it last year. Absolute value. The V there gives you a clue. It's shaped like a V, and its equation is exactly what you think, the absolute value. All right? Make sure you're keeping your squaring function and your absolute value function separated. The squaring, remember, is a curve, U. Absolute value is a V. They have many of the same characteristics, but they are different shapes. All right, now for my least favorite function. I'm sure you think I love all things math. I do love this. This one causes us all kinds of issues when we start trying to fill in all this stuff over here. This one is a nightmare. My least favorite BFF. Put a dot at the origin, solid dot. Then with your pencil, actually shade over one block and put an open circle. So just one block, shade that in. Then make a step up, go up one, put a closed circle, shade over one, open circle. And then you just keep doing that. So up one, over, up one, over, and it goes both directions. Last year, you probably referred to this as a step function. That name certainly makes sense. This is a step function. The equation, there are two. If you use your textbook, they use this kind of notation, a bracket. If you use your calculator, it says INT. X. I don't care which notation you use. Whichever one you think is the easiest for you to remember, that's the notation you're going to use. Okay? Logistic. And this is the wackiest. Logistic has the hardest equation. Its equation is 1 over 1 plus 1 over 1 plus e to the negative x. So 1 over 1 plus e to the negative x. And that is the same e that was in the exponential. Remember the exponential function? Y equals e to the x. That's called Euler's constant. It is a number like pi. And a picture of the logistic function. This one's kind of like the sine and cosine. It's all between 1 and negative 1. So I'm going to count up a few blocks. I'm going to put an asymptote and call that 1. Just so my picture isn't so scrunched. And then I'm going to put another asymptote at 0. And then I'm going to draw my squiggly line. Whoops, I didn't do a very good job there. My squiggly line. On this end, see how it's getting closer to the asymptote out this way? And on this end, it's getting closer to the asymptote out that way. So that one kind of looks like a sideways what? What other function was a squiggly? The cube. Cubing goes up and down. This one is sideways. Okay? Now, you are responsible for memorizing the name, the shape, and the equation for all 12. Make some flashcards to help you. Set them up however you study best. But you have to be able to come in and draw a sine curve on the board. If I say, Allie, draw a sine curve, you need to be able to do that. The hopes and dreams of the entire class will be riding upon your ability to do that. So make sure you know how to do it, okay? All right, so we got 12 of those. I think they should all be memorized. When do I see you again? Tomorrow, not by tomorrow. When do I see you again after that? Thursday? They should be memorized by Thursday. Okay? So we're gonna work with them now. Now the rest of this period and tomorrow, we're gonna practice with them. You're gonna make your flashcards. You're gonna use your flashcards in class today and tomorrow, or your sheet here, to help you answer the questions. But by Thursday, we'll be flying solo. All right, so let's look at our notes now. 1.3, it says sketch. This is not something hugely fancy. You're not plotting a bunch of points. You're simply drawing a sketch based on what you know from your BFFs. All right, let's start with these. Jake.
Did we put a point at one and then like the pyramid thing?
Okay, first of all, he says it's gonna be a V,
Yes, absolutely.
right? Because it's an absolute value. So any absolute value is gonna be a V. This one, we stuck a +1 in there. Now, here's where we might need a quick review. There's a difference between putting the +1 there and putting the +1 here. So you gotta pay attention to that. That makes a big difference in the picture. They're both B's. Anybody know what happens to either one of them? Lauren?
Is the one where it's outside the absolute value where it goes to the left?
No, other way around. This one is gonna go up 1. So this one would go up 1. This one is going to go left 1. Okay, we need to memorize that. So if you put the 1 inside the absolute value, Finn, my dear, are you paying attention?
Yeah.
Okay, all the actions up here, buddy. All right, if you put the +1 inside the absolute value, that's gonna move you left and right. If it's +1, it goes left. If it's -1, it goes right. If you put the number 1, in this case, outside the function, so here's my BFF, and then I put a +1 on it, that moves you up and down. So this is gonna be a V, and your sketch is just gonna be this. You're gonna tell me where your new origin is. Used to be here. Shifted it over. There it is, done. Now look at this one. Pay attention. There's a difference between this and this. This -2 is inside the parentheses with the X. Just like this one was, inside the problem with the X. When that happens, you're going sideways. Which way is this one going? Right to, what shape is it? Parabola. Isn't it a squaring function, kids? Look at your note cards. Look at your
Yeah.
BFF sheet.
Yeah.
Squaring functions are parentheses. Or squaring functions are parabolas. Okay. Now, all right. Tell me what's happening in this picture first of all. Which way is it going? Down 2. Everybody agree? Okay, so let's refresh our memories what the original looks like. The original has an asymptote at 0 and an intercept at 1, 0, and it looks like this. That's the original. Now, if you are moving this picture down 2, So pretend you cut it out and glue it down to, are you changing this asymptote? No. That asymptote is still going to be right here where it was. We're going to take the whole picture and move it down. So this point, instead of being 1, 0, is now going to be 1, -2. Does that make sense to you? And it looks like that. Now, please don't think your pictures have to be anything like super precise. They don't. I'll be looking for things labeled that I labeled in my regular picture, so asymptotes and intercepts, if I labeled them in the beginning, and then where are they now after we make the move. D is kind of a trick one, because we haven't talked about negatives. Does anybody remember what happens to our picture when we put a negative out in front of it? What did you say, Kara?
Does it flip?
Flips it upside down. That's exactly right. Technically, it's called a reflection across the x-axis, but we'll just call it upside down. So let's remember which function is this, which BFF? Reciprocal. So let's remember what it looks like. It has asymptotes on the axes and looks like this, right? Remember that? So now when I tip that upside down, what's gonna happen?
Go on top of the
This is now gonna be up here, right? And this one's gonna be down here. Now, the shape is exactly the same. The asymptotes haven't changed. It's simply been flipped upside down. Any function that you put a negative in front of it, that's what happens. Would you try E and F on your own, and maybe check with your partner, your table mate? Look at them carefully, make sure you're moving them the right way, and make sure you're starting with the right shape. Look at your BFFs. Yeah.
So for, never mind. Actually,
All right, so what shape am I starting with here? Just what's the shape I'm gonna draw? Square root function, which has a dot at the origin and shoots out like that, right? Now, what has this done to it? How has that moved it? Up 1. So now the dot isn't at the origin anymore. Now the dot is 0, 1. And it still has exactly the same shape. There is a lot to remember. A lot to remember. If the number is outside, here's your function. If the number's outside, that's up and down. If the number is inside with the x, that's left and right. And inside, plus means left. Kind of backwards, how you think about it, but that means left. All right, well, speaking of which, what shape is this? It's gonna be your cubing function. The cubing function, remember, goes through the origin and squiggles like that.
No.
So now what's happening?
Right.
Right 2, so that point isn't at the origin now, it's at the point 2 comma 0. And we're gonna draw exactly the same shape, squiggling through that point now, just like it used to squiggle through the origin. All right. G's a tough one. And the reason it's tough is because you really have to pay attention to what's happening. So tell me, what is happening to this picture? What's happening to it? How's it moving? Up 2. So I'm gonna start with my basic sine curve. Now remember, the sine curve goes up to 1 and down to -1. That's what a sine curve does. It goes through the origin, has a hill and a valley, and a hill. There is your sine curve. Make sure that's what you're memorizing. Now, we're gonna take every single one of these points, just cut it out and paste it up too. So this isn't gonna be the origin now, isn't this gonna be up here at 2? That point's now up here at 2? Now, this point right now is up 1, so it's actually going to be up to 3, right? 1 up 2. Now this one is at -1, so where's it gonna be? Regular 1? Remember, you're taking it up 2, -1 plus 2. So here is your sign picture. And of course, the same thing happens back here. So, when I grade this paper, I will want to see that sine curve bouncing back and forth between what and what? 1 and 3. Which makes sense, because the original goes between -1 and 1. And if you shift it up 2, it would be 1 and 3. Does that make sense to everybody? Those are probably the hardest. All right, I'm gonna stop after we do our last 2 here, okay? Let's see if we can get through these last 2. Okay?
Would you just, because it starts out on, like, right above it on 1, so it'd just be over here kind of.
Okay, so Jake says the original curve, this is an exponential. The original curve has an asymptote at 0 and an intersect at the point 0, 1. That's what should be on your note card or on your BFF sheet. That's what you'll memorize. This takes that picture and pulls it down 1. So where is that going to be now if it comes down 1? It's going to be right where he said. Isn't it going to be on the origin? But now what about the asymptote? It's moving too. Everything, the whole picture comes down 1. So where's my asymptote now? -1. And there's my picture. All right, last, oh no. Okay, Jake's got his hand up again, I love Jake, but I need somebody else who's hand, Robbie.
Would it just be an upside down view from the
It would
origin?
be an upside down V from the origin. Why is it upside down?
Negative.
Why is it still at the origin? There's nothing added or subtracted, right? And that's how we move it, we add or subtract things,
Yeah.
okay? Alright. Alright. Now I'm done, I'm gonna have you do a problem for me now on the board, either by yourself or with somebody. I'm gonna give you a challenge problem now. Alright, lots going on in this problem. Can somebody come up and graph this one? Think about what shape it is, and think about what's happening. And more, oh yeah, more, come on up. Go up, come on up. Hold on to it. You can draw it there. Somebody else can draw it down there. And you can draw it over there. Don't erase my math for you. Alright. We'll see how many of you get right. And all the rest of you should not be packed up and out of the room. The rest of you should be trying this, right? What shape? A parabola. We've made some changes to the parabola. Drew, we need to label our vertex. Would you do that for me? Give me the ordered pair.
What order do you do it in?
X, comma, Y. So sideways. So how did you move
Okay.
it? You did it right. No, I did it right. You went left one and up two. I don't know if that's right or not, but that's
Wait,
that's
I'm just
where that
asking,
point
like,
would be.
So then flip, do I move this first or do I flip it?
It really doesn't matter, but if you follow the order of operations that they always do. In this case, it doesn't matter. So in it, you do in parentheses, take care of them, and get out of the It really doesn't matter.
So it doesn't matter. I don't know.
We shall see. We've got,
I don't know if I did it
all right, we've got red, orange, purple, and another purple. Okay, so what do you guys think? They're not all exactly the same. What do you think?
I would say,
Are they all upside down correctly?
yeah.
Yeah, that's because they're negative. Did they all go left one?
Yeah.
Yep, perfect, because of this. What does that mean? Down to,
Okay.
down to, you went up to. So you graphed it as though it had been this. You would have the right picture from coming down.
What I, like, cause like I would, like if you did the parabola, if it were positive and then went down two and flipped it, would that have been right?
So if you.
So I was just asking
so
like when you flipped it.
Negative 1, 2,
Yeah,
right?
and if it were
So
up,
it would look like, oh, if it were up.
and like I was asking like when you did the negative.
Okay, now, if you turn that upside down, that doesn't change the vertex.
Oh, you're right. Well, it, wait, like flipping over the,
I'm not reflecting it across the x-axis.
it just makes it, oh, you're right.
Just
Yeah.
flip it upside down. Okay, all right, well, good job, folks, that was a toughie. Okay, so we got our work cut out for us. We have some homework due.